When we were talking about SI units, we had learned that the amount of substance is referred to by N and its SI unit is mole. In this video, we are going to be studying about that beautiful concept. So, relative atomic masses of elements were determined by various methods, and we used carbon as the standard. But there was still no way where we could actually count the number of atoms present in a particular sample, and that was a huge issue. So, what was found was 1 gram atom of any element. Okay, sorry. What was found was 1 gram atom of any element consisted of consists of the same number of atoms. And 1 gram molecule of any compound or substance, rather, because substance, we use the word substance over here because a molecule could mean an element or a compound. So we use the word substance here. So 1 gram molecule of a substance, which means it could be an element or a compound, consists of the same number of molecules. So this was a huge, it was a huge, a big finding, and this meant that there was a number which was experimentally determined, and it was found to be 6.022137 into 10 to the power 23, which is the Avogadro's number. For ease, we will use it only up to 6.022 into 10 to the power 23. Now, this number is very essential when it comes to various calculations that we do in chemistry. So, Avogadro's number is defined as the number of atoms present in 1 gram atom of the element, or number of molecules in 1 gram molecule of the substance. So, this number, and this is simply written as mole, MOL, which is the SI unit of the amount of substance that is present. So this just means that one of a substance will contain 6.022 into 10 to the power 23. So when we talk about hydrogen, okay, yeah, so let's do hydrogen. So when we talk about hydrogen and we talk about atoms of hydrogen, so 1 mole of hydrogen atoms will have 6.022 into 10 to the power 23 atoms of hydrogen, and 1 mole of hydrogen molecules will have 6.022 into 10 to the power 23 molecules. Okay, so each molecule of hydrogen has 2 atoms. So the number of atoms in 1 mole of hydrogen molecule would be 2 into 6.022 into 10 to the power 23. Generally, when we say 1 mole, okay, let's say, for example, 1 mole of oxygen. So when we say 1 mole of oxygen, we automatically mean 1 mole of O2, because O2 is its basic state of existence, right? So unless and until specifically mentioned, you need to assume that that particular substance is in its most stable form, which means 1 mole of O2 or oxygen. See, if I say O2, it means O2 molecule, obviously. If I say oxygen atom, it would have been O atom. So O2 is 6.022 into 10 to the power 23 molecules. 1 mole of electrons is 6.022 into 10 to the power 23 electrons. Like how we have a dozen dozen automatically means we're talking 12, right? So similarly, mole automatically means we are talking about the Avogadro's number. And the Avogadro's number is the number of atoms present in 1 gram atom of an element, or number of molecules in 1 gram molecule of that particular substance. And obviously, sometimes mole might be too big of a number to convey. So you have millimole, you have, which is equal to 10 to the power minus 3 moles. You have micromole, which is equal to 10 to the power minus 6 moles. Similar to how we spoke about kilograms having representation in terms of grams as well, our moles is also represented as millimoles, micromoles. Okay, and according to the Avogadro's hypothesis, as we told before, Avogadro's hypothesis stated that if you have two gases, assume you have two gases with equal volumes and they are in equal amount of equal temperature and pressure, then the number of atoms in these two cases will be the same. So the number of molecules will be the same. So when we think about 6.022 into 10 to the power 23 particles, and which are in standard temperature and pressure. So standard temperature is 0 degrees Celsius and pressure is atmospheric pressure. Then the volume was experimentally found to be 22.4 liters. Okay, so we have so many particles, molecules at standard temperature and pressure for two different gases. Then the volume of both these gases is 22.4 liters. Okay, and this was experimentally calculated, and this is also called as molar volume. Okay, so the definition of mole, there are three different definitions that we need to remember. The first one is with respect to mass. So the amount of substance which has mass equal to gram atomic mass if the substance is atomic, and gram molecular mass if the substance is molecular. This basically means that 1 mole of carbon atom equals to 12 grams. Okay, so here the atomic mass of carbon atom is 12 U, and gram atomic mass of carbon would be 12 grams. Basically, gram atomic or gram molecular mass is the conversion of this value from U to G, that is grams. Okay, so 1 mole of carbon atom has 12 grams, is equals to 12 grams, whereas 1 mole of carbon dioxide molecules will be equal to, this carbon is 12, oxygen is 16, 2 times plus 12, their molecular mass is equal to 44 U, which means 1 mole of carbon dioxide will be equal to 44 grams. So here it is with respect to mass. The second is with respect to number. So here the amount of substance which contains Avogadro's number of atoms if the substance is atomic, or Avogadro's number of molecules if the substance is molecular. So mole is defined as the amount of substance. So this means, 1 mole of carbon atom will have 6.022 into 10 to the power 23 atoms. 1 mole of carbon dioxide will have 6.022 into 10 to the power 23. Is it atoms or molecules? It is molecule, because this is a molecule. So molecule. This is the previous definition. First thing that we studied is this only. So 1 mole of carbon atom will have 6.022 into 10 to the power 23 atoms, and 1 mole of carbon dioxide will have 6.022 into 10 to the power 23 molecules. The third definition is with respect to volume. So let's take 1 mole of oxygen gas will have 22.4 liters of volume. Okay, or rather 1 mole of oxygen gas is 22.4 liters of oxygen at STP. So here, in case of gases, mole is defined as the amount of gas which has the volume of 22.4 liters. So even if I say 1 mole of carbon dioxide gas will have 22.4 liters of carbon dioxide at STP. So 1 mole can be, okay, so basically over here we are taking three definitions. The first is in terms of mass. Here we will be considering the gram atomic mass and the gram molecular mass. So 1 mole of that particular element's atom will be equal to 12 grams. Next, we're talking about in terms of number. So 1 mole of the carbon atom will have 6.022 into 10 to the power 23 atoms. So number of atoms, that's how we say number. And in terms of volume, in case of gases, mole is defined as the amount of gas which is the volume of 22.4. So 1 mole of oxygen gas will have 22.4 liters. 1 mole of carbon dioxide will also have 22.4 liters, but here it will be oxygen at STP. Here it is carbon dioxide at STP. Remember one thing, the concept of mole is very essential when it comes to solving various numerical problems in this chapter. And if you haven't understand the concept of moles, it automatically becomes very difficult. All you need to understand is this: 1 mole of that particular substance is generally equal to 6.022 into 10 to the power 23 atoms or molecules of that substance. So we are talking that in terms of mass and volume. Okay, so for various calculations that you will do, I would like to point out a few important things. So for atomic substances, 1 mole equals to 1 gram atomic mass or 1 gram atom. And in case of molecular substances, we will say that 1 gram molecular mass. This is equal to 6.023 into 10 to the power 23 atoms or molecules, whichever it is. Also, this is equal to 22.4 liters at STP because we're talking about volume as well. Okay, so yeah, so do remember these how this is different. I would like to do that once more. In terms of mass, 1 mole of that particular atom or element will be equal to the gram atomic mass if it's an atom and gram molecular mass if it's a molecule. And if we're talking about number, 1 mole of the carbon atom will have 6.022 into 10 to the power 23 atoms because it's an atom, and if it's a molecule it will have 6.0 Avogadro number of molecules. In STP, that is standard temperature and pressure, 1 mole of oxygen gas will have 22.4 liters. This is very important. 22.4 liters of oxygen at STP. So in this video we had studied two important things: the Avogadro's constant, whose value is generally taken to be 6.022 into 10 to the power 23, and when we have Avogadro's constant as the number of molecules present in a gas at two different gases at STP, the volume of that particular gas becomes equal to 22.4 liters. These two values, this value does not change. At standard temperature and pressure, this value does not change. With that, we finish this topic of mole concept. One more thing I'd like to say right now is that in this set of videos, we are dealing with NCERT questions in the end. of the chapter. So over there, I will be solving each of the questions given in the back of the textbook. But from the next chapter onwards, we will be dealing with individual topics along with their NCRT questions at the end of that topic. That's all for now. Do check out the next video.